In our last video, we looked at smoothing the surfaces on a sort of a cubical piece of aluminum. Now maybe you have a 4-jaw chuck and you'd like to try that out, but you don't have a suitable cubical piece of aluminum. Well, everybody has some cylindrical aluminum or bar stock, right? So this is 1-inch round bar. Now hidden inside of every piece of round stock, there's a piece of square stock trying to get out. So all we have to do is machine away these 4 sides and then we'll have it. Now I know all of you were paying attention back in high school math class when the teacher was talking about some Greek guy named Pythagoras. And we know from the Pythagorean theorem that a squared equals b squared plus c squared. You remember that, right? But the bottom line here is that for a 1-inch diameter piece of stock, round stock, the largest square that will fit in there, or that you can take out of there, happens to be 0.707 inches on a side. And that, of course, is because it's the square root of 2 over 2. Square root of 2 is 1.414, which takes us to 0.70. But a good rule of thumb then is to remember that the largest inscribed square will be 0.707, or about 0.71 inches per inch of diameter. So of course if it was a 2-inch diameter, it'd be twice that. I'm sure you have good memories from those days back in math class, but let's move on. To help guide our cutting efforts, I've taken the workpiece over here to the layout table, surface plate and height gauge, and put some layout die on the end. And now I'm going to scribe some lines that will help keep us on track when we get over to the lathe. Now ideally I would have a way to make sure these are perfectly square, but since this is just a demonstration, it doesn't need to be perfect. So now we're ready to machine away those 4 sides. Pretty much any time I do a job on the lathe or the mill, if I have some leftover scraps, I throw them in this little bin. I have several like this, and these scrap pieces are very handy for future projects, but in this case I just need a piece of thin flat stock to act as a spacer. I've gotten the jaws lined up about where they need to go, and I'm going to slip this spacer in behind here, and that will line up the work so that it's parallel with the face of the chuck, and then I can tighten the jaws down. So I want to keep some pressure on that as I'm tightening the chuck jaws so it stays in position. And once I've got that snugged up, I can pull this spacer out from behind there and then tighten the jaws a little bit more so that they're secure. Alright, so now you can see with our scribed line there, we can just work down to that line with our cutting tool, and then we'll flip it over and do the 3 remaining sides. As far as lining the workpiece up between the jaws, I haven't done any real measurements for that. I just kind of eyeballed it to get approximately equal amounts of the workpiece above and below the jaw, and that's really mainly for balance. Go back to our diagram. If you subtract 0.707, which is the length of the side of our square, from 1, which is the diameter of our round stock, that gives you whatever it is, twice 0.146. So on each side we want to go in a depth of 0.146. To measure our depth, I'll bring the tip of the cutting tool up flat against the side there, and then I'm going to zero the collar here on the compound feed. Now from our last video you may remember that I have the compound feed set so that it's parallel with the ways, and because of that I can use the calibrations on the compound hand wheel, this little scale here. I'll set that to 0, and now I can read my feed depth directly off of this scale. And now I'm going to use my shop-made carriage lock so that the whole carriage does not drift back when I'm making my cuts. With the cutting tool now clear of the edge of the workpiece, I'm going to advance the compound feed by 20 thousandths. We'll use that as our initial cut depth. And once again, as with our demonstration in the last video, we're taking an interrupted cut over part of the surface of the work. When the workpiece is in the vertical orientation or around that side, the tool is not in contact with the surface. As we go in deeper, of course, it will stay in contact for a longer amount of time, but it's only contacting the work during part of its rotational cycle. Take it in a number 30 thousandths this time. So that's a total of 50. I think we'll go in another 30. So you can see the flat area is getting wider as we go deeper. For this type of operation, you may want to keep a tally of how far you've advanced the tool, because unlike with a digital readout, the scale on the compound doesn't give us any clue as to how far we've gone so far. So I started with an initial cut of 20 and then 3 cuts of 30 thousandths. So this is my cumulative depth is 20, 50, 80, and now 110. So if I keep going, I'm writing sideways here, I go to 140, and our total depth we want is 146. So we'll now need a final cut of 6 1/1000ths, which will take us to our target of 146. Okay, with the camera repositioned here, you can see our scribed lines provide a good check to make sure we're actually where we think we are. So pretty close. I'm going to try advancing it a 6 thousandths for this last cut, but that doesn't look like it's going to be enough. So I'm wondering if I forgot to record one movement there or something. We'll see. Well, we're not quite up to our line there, so I'm pretty sure I missed something. But I'm just going to leave that for now, and we'll flip it over and do the other side. We can then measure with our calipers and figure out how much excess we have there, and then take care of that later. Okay, now we need to flip the work over 180 degrees to work on the opposite face. I'm going to loosen jaw 1 and jaw 2 and leave jaw 3 and 4 in their original positions. Now I need to stick my spacer back in here, and I put the now flat side up against there. Tighten jaw 2, tighten jaw 1, and then remember to move my spacer out. You've got to be very careful if you use a spacer like this. You remember to remove it before you start the lathe up, otherwise could come flying out and whack you in the face or do some other type of damage. Just do an extra check and make sure all 4 jaws are tight. Anytime you readjust the jaws, you want to be sure that they're secure before you start up the lathe. Now, I'm going to have to re-zero the tool. It's actually pretty close to 0 now, but as we did in the beginning, I'm going to back off the tool a little bit and then bring it up flush with the work. I've got the compound feed set to a 0 mark. I'll bring my tip of my tool up to contact the work, Then lock the carriage down, move the tool back out of the way, and then I'm going to dial in 30 thousandths on the compound feed. That will be our initial depth of cut, so I'm going to write that down this time. Now I'll advance it another 30. Another 30. Okay, another 30. And that will take us to a total depth of 120 so far. Alright, so I need a final cut of depth 26 to take us to 146. I want to take that in two passes, 20 thousandths deep cut, and then I'll take a 6 thousandths deep cut, and that's just to give us a finer surface finish on the final cut. So we'll dial in 20. Then for our final cut on this face, we'll dial in 6 thousandths. If we now look at our scribe line, it's pretty much gone. I like to think we're right on. It looks down at this lower edge where you can actually see a little bit of it. So I think it's right on, but we'll take the workpiece out of the chuck and check it with the our digital caliper. Okay, once again, we'll just loosen jaw 1 and jaw 2. Then we can take our workpiece out and let's measure it. See what we've got here. Looks like it's 735. It should be 707. So let's do the math and see how much we need to remove. If we subtract 707, which is our desired diameter, or thickness I should say, from 0.735, which is our actual measured thickness, we get 0.028 or 28 thousandths, which looks suspiciously like 30 thousandths. So I think I forgot to record one of my cuts while I was working. So we'll take another cut of 28 thousandths and see where we end up. This is the side that has the edge that needs to be machined, as you can tell from the scribe line there. I hope you can see that. So we'll put that face out. We'll put our spacer back behind there and tighten jaw 1 and then tighten jaw 2. And of course this is where having the punch marks beside each jaw helps me keep track of which jaw is which. I demonstrated making those punch marks, I think, in my first video on the 4-jaw chuck. Now we got to remember to remove our spacer here. It's pretty snug in there. And then we'll tighten all around just to make sure we've got a good grip on it. And then we're ready to go. Now we'll bring the tool up, touch the surface of the work. Now I'm going to set the compound feed to 0 mark. It's easier to do that first, and then bring the tip of the cutting tool up against the work, and then we'll lock our carriage lock. Now, one other thing I wanted to comment on, I like to work with the compound feed when I'm using it like this, or really anytime I'm using it. I don't like to have the compound feed extending out over the end of this support base if I can avoid it, because as it gets hanging out there, you know, it's sort of cantilevered out over nothing, and there's a greater tendency for the tool to dig in and give you chatter. Whereas if you keep the compound back over this more solid part, then you are less likely to get chatter and you'll get better quality cuts. I didn't want to take a total cut of 28 thousandths, but instead of taking that all in one pass, I'll take a pass of 20 thousandths and then a final cut of 8. So we'll dial in 20 thousandths, and that will be our first cut. Now I'm going to dial in 8 more thousandths, and that will be our final depth. Okay, we've got a nice clean face there. Let's take it out and measure it. Well, there's our finished workpiece. Not finished, but half finished, I guess. And you can see the cut marks are pretty close to our scribe lines, just a little bit off as far as the angle goes, but nothing of real concern. So let's check the measurement with the digital caliper. And there we have it. It's about 0.707 minus a half a thousandth, so it's 706.5 thousandths. If I measure it again, I'll probably get something a little different. Yeah, 706.5. So that's pretty close. You know, if I had not been making a video and I really wanted it and needed it to be exactly precise, I would have taken more care, but this is pretty good considering the circumstances. Well, now, of course, we need to work on these two remaining sides. Basically the same process, but we'll need to readjust the chuck jaws. Well, these two jaws are about the right distance apart once I tighten up the number 2 jaw. So I'm going to just snug up the number 2 jaw to hold it, get a little bit of a grip on it so it doesn't fall out of the chuck. And now I'll slip my spacer bar back here and tighten that a little bit. Now I need to bring these other 2 jaws down and get a grip on the sides there. But I want to have it approximately centered in the, well, what's now the vertical plane. Alright, now I'll snug those down. Hopefully it'll stay in place now. If you look at the clearance above and below the workpiece here, you can see that it's not well centered, so we'll play around with that a little bit. So I'm going to loosen this upper jaw, happens to be jaw number 3, and then we'll flip it over 180 degrees and we'll tighten the opposite jaw, which is jaw number 1, and that should bring it closer to being on center. Should be pretty close now. Looks almost even up above and below the jaw. It's about equal amounts of stock. So I think we'll call that good enough. Next we'll bring the tip of our tool, our cutting tool, right up against the surface of the work. And I want to hit that center point there pretty close to it. I don't want it to be down here somewhere. I want it to be right on the highest point there so we get an accurate depth. So we'll bring that in. First let me zero my compound feed. Now we'll bring the tool in, lock the carriage down. Okay, so we're set now. Let's dial in 30 thousandths. I'm going to start a new worksheet down here. Well, this time I've written down my planned series of cuts here. So this is number 1, number 2, 3, 4, 5, 6. So we're going to make 6 passes over the work, and we'll take 30, 30, 30, 30. And then the last 2 will be 20 and 6. And here's the cumulative depth. It's 30, 60, 90, 120, and then 140, and our final to 146. So now all I got to do is make a check mark when I've completed each of those passes. This is a good thing to do when you don't have a digital readout and you're just working from the hand wheel scale, calibrated scale on the hand wheel. It's real easy to lose track of where you are. And had I not had those guidelines marked out earlier, I might well have undershot or overshot and ended up with something different than I wanted. So that's an advantage to having those scribed lines on the workpiece. It gives you an independent sanity check in case you slip up somewhere along the way. Okay, and I'm going to dial in 30 thousandths for our first cut, and then we'll start it up. Alright, so we've got our first cut. I've made my check mark. I'm going to dial in another 30, 10, 20, 30. Another reason why it's not a bad idea to keep a sort of a log sheet, as I showed you, is that as you dial in 30 repetitively, this dial has 40 thousandths around it, and so the number you see on the dial isn't 30. It depends on where you were last, so it's going to be 20 this time. And then I'll go around another 30, it'll be 50. But of course there is no 50, it's going to be 10 at that point. So these numbers, until you get used to what's happening, can be a little confusing or misleading. One other thing I wanted to show you is that in this cutting operation, the chips are being thrown at fairly high speed directly back to where I'm standing in a lot of cases. Naturally, I have my safety glasses on, but I would normally use an additional safety shield just to keep those chips from hitting me in the face. So I wanted to show you that. One option is to use a full face type shield like this one. This is a cheap one from Harbor Freight, probably cost $2 or $3, maybe not even that. And it works okay, but I find this plastic sometimes makes it a little harder to see, and of course it gets dust and oil built up on the surfaces here, which make it harder to see. So I don't usually use this. I use it sometimes for grinding operations or in other situations, and I probably should get a better one, but this has done what I needed for now. These are the safety glasses that I wear. And of course these have side shields, which are important. They're shielded around here so that where your face curves around, it's better protected from chips getting up underneath there or in from the top corner here. But even so, when you're working on a job like this, it's not unusual. If you work with a lathe long enough, you'll find that chips can still sometimes get down in there, not usually with enough force to cause any harm to you, but enough to make you think about it. The other thing I wanted to mention is these are actually magnifiers. They're like reading glasses, and these have a 2.5 diopter magnification on them, and I think I paid about $15 for them or so. I've used different varieties over the years, but if you're older and you have your eyesight's not so great focusing up close as it once was, these are a good option. And I have these in several different diopters that I use for different purposes. And I have probably 10 pairs of these I keep around the shop. This is the supplementary chip shield I like to use, and I use this together with my safety glasses. I would not ever trust this to use without the safety glasses, but it helps in situations where you have a lot of chips flying as an extra shield. And if you get it adjusted properly, then you don't get much glare off of it. And I clean this, I just wipe it with a soft cloth or a paper towel, just dampened with some Windex. And this is just a piece of acrylic about an 1/8 inch thick. And this bend here I made using an electric bender jig that I made many years ago, back in 1999 I guess. And somewhere out on my website you can find some plans or what I did to make this, how to make your own. But you can also just scribe a line on here with a ruler and a metal scribe, and just move this back and forth in the flame of a Bernzomatic torch or similar torch until this softens up, and bend it that way, and that works pretty well. But the bend just helps give you better shielding and coverage. I should also mention that this magnetic base on which I have the shield mounted came from Grizzly. And as you can see, this is what I would call a normal size magnetic base indicator holder. And so you can see this is an extra large one. I got that from Grizzly. I think LMS may sell similar ones now. I'm not sure of that. But anyway, it's real handy. You can just move the shield up out of the way or over here, or when you need to get access to work on the chuck. It's easy to get it out of the way quickly. So let's move on. Now you may be able to see that in addition to the chips flying off, I'm also getting these spirals of aluminum, which if they happen to snap up and hit you in the face of the eye, could do some damage. So that's the benefit of having this extra layer of safety shield between you and the work. So I dialed in 20 thousandths. Now we'll check against our scribed line, and it looks to me, let me get the camera over here, there's 10, 20, 30, and that would leave us with a final cut of 6. I think we'll try that. That looks about right based on where the tip of the tool is. Alright, that looks pretty good. So I think our final cut of 6 thousandths will take us where we need to be. So I'll dial in the 6 thousandths. We'll start it up. I'm not going to put the chip shield in place this time because we're taking such a light cut there won't be a lot of chips. But of course I have my safety glasses on. Okay. Looks pretty good. Let's take it out and measure it and see where we are. I have this little LED lamp here. It's magnetically held in place on the back of the headstock, and it does a pretty good job of getting light down in there close to the chuck. So I'll go ahead and, I should have used that earlier I guess, but and of course the LEDs are pretty much impervious to almost anything, you know, chips and cutting fluid and so forth. So it and you can move it around and get it where you want it and adjust for glare. All right, well, once again we will loosen jaw 2, loosen jaw 1, take it out and look at it. Looks okay, and we got one final side to do here, and then we need to do the 2 ends, although one of the ends is finished. But let's go ahead and get this other side done. Alright, and we're ready to make our last pass here. We'll follow the same procedure we did before. So, and I also wanted to mention, it's not necessary to stop the lathe in between passes. I was doing that primarily just to cut the noise down so you could hear my commentary. But if I was just working on this for myself, I would leave the lathe running in between cuts. Okay, I've got 2 cuts left to make, one of 20 thousandths and one of 6 thousandths. So I'll dial in 20 thousandths, and then we'll take a final cut of 6. And our final 6 thousandths. See how the scribe line looks. Well, we're right on it, so I think we're where we want to be. One other thing I wanted to mention is, you notice I never said anything about what RPM I was using, and the fact of the matter is I don't know what RPM I'm using. and I don't really care. But the good thing is that when you work with the lathe a lot with different materials, you'll soon learn, what speed feels right and sounds right. Harder materials like steel or stainless steel, generally you're going to use a slower rotational speed or RPM, and soft materials like aluminum or brass, you can generally go faster. But I usually tend to run things slower than I could, because as long as I'm getting a good quality cut, it doesn't matter too much, and it does add a little bit of a safety. Obviously, the faster the chuck's spinning, the more potential there is due to centrifugal force for the workpiece to be thrown out if it's not in there securely. And secondly, if you happen to get your hand in there by mistake somehow, the faster it's moving, the more damage it's likely to do. Or if you left the tool up here on the top of the headstock and it rattled around and fell down in there and shot out, by running the lathe at a lower speed, your risk is lowered somewhat. So those are my thoughts on that. Different people have different opinions on that, but for home shop work, you have a lot of latitude on your speeds and feeds. So especially if you're new, don't be overly concerned with that. Start with slower speeds and slower feeds until you get a good feel for what works and how things sound. And pay close attention to the sound, because often your first clue that something's not right, for example, that the work isn't in the chuck properly, or maybe you forgot to tighten one or more of the screws on the back of the chuck, sound is often your first clue to something not being right. So if it doesn't sound right, shut it down and check it out and find out what's causing that variation in sound. Check our dimensions, and we're 714 there on that dimension, and our goal was 707, I guess. So we're a little bit over there, and we're about 710 on this side. So we're slightly over, and if you're going to be over or under, it's better to be over, because you can still go back and take a correctional cut if you need to. But again, this is a demo, so it's not going to be used for anything. So if it's off by a few thousandths, I'm fine with that. The goal here was not to be real precise, but rather to show you the general methods that you use to get there. And again, I mentioned in a previous video on this work in the four-jaw, once you clean up one face, on subsequent passes you're going to end up getting jaw marks on the work. And the way to avoid that is get some thin aluminum or brass shim material and put it between the chuck jaw and the clamping surface, and that will keep your surfaces in good shape if you need them to be. Well, our only two remaining faces are here on the ends, and this one happened to have previously been turned in the lathe on this workpiece. This end was saw cut. Fun, just to complete the job, I'll go ahead and finish up that face. Now obviously, to grip this piece, to grip it in this orientation, we're going to have to change the chuck jaws around. I'll just hold my workpiece in here, and just by eyeball, those two jaws are pretty close. So I'm going to bring in these others to jaw number 4 and jaw number 2, and try to get that roughly centered. Okay, that looks pretty good. I wouldn't guarantee that it's exactly centered. In fact, I'm quite sure it's not exactly centered, because I didn't do anything more than eyeball it. In a subsequent video, a future video, I'll show you how to go about centering this if you need it to be exactly centered. But for now, I'm just going to go ahead and take a facing cut here and call it done. Of course, if this was a real workpiece, we would be trimming it down to some final dimensions, so we would have to know what that dimension is, use our calipers to measure the workpiece, and then set our cross feed accordingly to end up with the desired final length. I'll feed in a few thousandths and make that cut. So that's all there is to it, not much. An easy job. Actually, it looks like I got pretty close to center, considering that I didn't do any measuring to get there. This little characteristic bullseye pattern here, you can see, is almost centered. It's not quite, but it's close. Alright, so that's it for now.